Welcome Shemsters to computer class. Yesterday we studied communication protocol like HTTP, FTP, TCP, IP, etc. Today we are going to start with wireless or mobile computing. This section is going to discuss about wireless and mobile computing technologies. But before discussing various wireless and mobile technologies, we must be clear about what wireless and mobile computing is and the difference between the two. Let's first discuss these two differences. Wireless refers to method of transferring information between a computing device such as a personal data assisted, which we also call it as PDA, and a data source such as an agency database server without a physical connection. Not all wireless communication technologies are mobile. Mobile simply describes a computing device that is not restricted to a desktop. A mobile device may be a PDA, a smart cell phone or web phone, a laptop computer, or any one numerous other device that allow the user to complete computing tasks without being tethered or connected to a network. Mobile computing does not necessarily require wireless communication. In fact, it may not require communication between devices at all. Wireless communication is simply data communication without the use of landlines. This may involve cellular telephones, two-way radio, fixed wireless, laser, or satellite communications. Here, the computing device is continuously connected to the base network. Mobile or untethered computing means that the computing device is not continuously connected to the base or central network. Mobile devices include PDA, laptop, and many of the today's cell phones. Following list gives you an idea of different computing devices which can either wireless or mobile or both. So here we can see stationary computer. It is neither wireless nor mobile. Notebook in a hotel. It is not wireless but it is mobile. Wireless LAN in historic building. It is wireless but not mobile. PDA is both wireless as well as mobile. Today's smartphones and pagers, these are both wireless and mobile. Wireless mobile computing technologies. First, let's talk about GSM. GSM is short for Global System for Mobile Communication, which is one of the leading digital cellular system. The GSM standard for digital cell phones was established in Europe in mid-1980s. GSM has now become the industrial standard in Europe, Australia, and much of Asia and Africa. In covered area, cell phone users can buy one phone that will work anywhere where the standard is supported. To connect to specific service providers in these different countries, GSM users simply switch subscriber identification module, that is SIM card. SIM card are small removable disc that slips in or out of GSM cell phones. They store all the connection data and identification number you need to access a particular wireless service provider. Unfortunately, the 1900 MHz GSM phones used in US are not compatible with international systems. GSM uses narrow band TDMA, which allows 8 simultaneous calls on the same radio frequency. Here TDMA work by dividing the radio frequency into time slots and then allocate slot to multiple calls. GSM digitizes and compress voice data, then send it down a channel with other streams of users, each in its own slot. GSM system use encryption to make phone calls more secure. GSM operates in 900 MHz and 1800 MHz band in Europe and Asia, and in 1900 MHz, sometimes referred to as 1.9, gigahertz band in US. It is used in digital cellular and ECS based systems. GSM is also the basis for integrated digital enhanced network, a popular system introduced by Motorola and used by Nextel. Now let's understand about CDMA. CDMA is short code for Code Division Multiple Access, a digital cellular technology that uses spread spectrum technique unlike competing systems such as GSM that uses TDMA. CDMA does not assign a specific frequency to each user. Instead, every channel uses the full available spectrum. Individual conversations are encoded with a pseudo random digital sequence. CDMA is form of spread spectrum, which simply means that data is sent in small pieces over a number of discrete frequencies available for use at any time in the specific range. All the users transmit in the same wide band chunk of spectrum. Each user's signal is spread over the entire bandwidth by a unique spreading code. At the receiver's end, the same code is used to recover the signals. Next is WLL, which means wireless and local loop. It is meant to serve subscriber at homes or offices. Wireless local loop is analogous with local telephone service but much more capable. A WLL system serves a local area by developing a multi-city of multi-channel transmit or receive base stations that are within line of sight of the intended customer. Each customer is equipped with mini station of low power into which telephone or PBX is connected. The WLL unit consists of radio receivers and the WLL interface assembled in one metal box. Two cables and a telephone connector are the only outlet from the box. One cable connects to the directional antenna and a phone receptacle to connect a common telephone set. A fax or modem could also be connected for fax or computer communication. Now let's understand about advantages of WLL. Lacking exterior plant reliability is greatly enhanced as well-designed WLL facilities do not significantly suffer from weather damage, vandalism and accidents. WLL system offers better bandwidth than traditional telephone system. Most important because WLL system has much better bandwidth than traditional telephone systems. Superior customer service feature and quality can be provided. WLL system supports high quality data transmission, signaling services and most advanced customer service features. Next is GPRS. GPRS is an abbreviation for General Packet Radio Service. GPRS is used for wireless communication using a mobile device. With this service, you can access the internet, send mails, and large data. You can also watch real-time news, download games, and watch movies. How does GPRS work? You must be aware of how files are transferred from one location to another on computer. They are broken down into packets and sent. Similarly, GPRS also uses the same function to transfer data through a network. The information is split into smaller units and packet and sent through the network and is reassembled at receiving end. GPRS provides a high-speed data transfer, typically between 56 kilobits per second to 114 kilobits per second. A user of GPRS network is charged only on the amount of data is sent or received as opposed to the duration of connection. Next, we are going to talk about 1G, 2G, 3G and 4G. First, here G means generation. 1G is considered to be the first analog cellular system which started early 1980s. There were radio telephone systems even before that. 1G network were conceived and designed purely for voice calls and almost no consideration of data service. 2G network, which includes GSM, CDMA, 1D, AMP, are the first digital cellular system launched in 1990s, offering improved sound quality, better security, and higher total capacity. GSM supports circuit switch data, that is CSD, allowing user to place dial-up data call digitally so that the network switching station receives actual one and zeros rather than the screech of an analog modem. Next is 2.5 G network. It supports 144 kilobits. And next is 3G network, which is UMTS, FDD, TDD, CDMA, and so on, are newer cellular network that have data rates of 384 kilobytes per second and more. Next is 4G network. 4G is all about faster internet speed. It offers no improvement in making call or sending text, but very fast web experience compared to 3G. 4G technology offers many advancements to the wireless market, such as downlink data rates well over 100 Mbps, low latency, a very efficient spectrum use, and low cost implementations. Students, that's all for today. Tomorrow we will continue same topic. Thank you, Shemstars. That's all for today. You can drop your queries on the Google Classroom. Take care.